I will show you how you can perform a basic modal analysis to find the natural frequencies in Creo Simulate, and how you can adjust the parameters to hit a specific target frequency. And finally, how the parameters affect the natural frequency. So let's get started. You can start by creating two new parameters and calling them length and L1, and you can give them the following values. Then you create a sketch, length divided by 2. Do you want to add this relation? Yes, I want length. Yes, and this should be L1. L1. Now you revolve it 360 degrees, and you can go to application simulation. You can give it the material by clicking here, material assignment. I have already done that. So you can go give it the titanium alloy, aluminium vanadium alloy with the following Young's modulus. And you click OK here, and then you go to, you don't need to have any boundary condition or constraint. You go to modal analysis. You can hit a number of modes from minimum frequency 0, but in our case, and this is a fatigue specimen, a uniaxial hourglass shaped fatigue specimen. So I'm interested in a little bit higher frequencies. You can give it a range too, but let me just, I'm interested in, say, 2 modes from 19,000 Hertz and forward. You can do different kinds of stuff. You can do single pass adaptive, multi-pass adaptive, but I'm going to let this be, change only this one, and maybe even call it something. Call it modal analysis. And run this. As you can see here, the first frequency is 20,000 Hertz. And you can look at the modal shape if you want. This is a uniaxial fatigue specimen, so it's in compression, tension compression, as we want. You can look at the other modal shape. So this is how you perform a basic modal analysis. Now let's say that we want to optimize the frequency. You can optimize the mass if you want, but I'm going to feasibility and choose modal analysis or frequency. Modal frequency. The description, if you don't know what they are, you can just click on them and look at the description. Modal frequency, and I want some frequency. Let's say I want 2500. I want a little bit more, say and I want to change the parameters. I want to change the length from, say, this is the current length, 59, and we had 20,000 hertz in the frequency. Let's say we want 20,500. Should we make it longer or shorter? We don't know. Well, let me from 550 to 70 and see. If you go here to study status, display study status, and you can see the final. You need to make it shorter. So 59 should be 57.88 to get the target frequency, 20,500. Yes, and this was the second iteration, and it was in the tolerances. So if you edit here, options, you can see optimization convergence. You can the value, it's around you can have 1% convergence. So 1% of 20,500 is 205. So yeah. Now we can make a new study, sensitive design study. Choose this and this length here. Maybe do 15 steps. And call this whatever you want. And run this study. Now we are going to see how the length affects the frequency. You can go display study status, and you can see here steps that it is running. When you go here, you can choose mode 1, measure. You can do modal frequency, let's say in kilohertz, and the length of the specimen, how it's affecting the natural frequencies. This is the frequency in kilohertz, so we want it in 20 kilohertz, and 50, somewhere around 56 and 58 we get the frequency that we want. And if you make the specimen longer, the frequency changes. So this is how you can perform a modal analysis and find the design parameters that you want. So, and you can change the different parameters and play around and see how they affect the natural frequency of the specimen. Yeah, don't forget to like and subscribe if you learned something. Thank you.